Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking both Lavastorm and Tableau for sponsoring today's event. Both companies have been longtime supporters of the Data Science Central community, and we are honored to have them sponsoring our webinar today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including MapR, Teradata, TIBCO, Hortonworks, Pivotal, and Cisco, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you've not had the opportunity to view them, I would encourage you to do so, as they do provide some very useful information. Today's webinar is entitled Combining Data Visualization with Data Management to Achieve Faster Results. Before we begin, I'd like to briefly review the format for today's webinar. Today's event will be approximately 1 hour long. We have two panelists that I'll introduce to all of you in just a few moments. We should have about 10 to 15 minutes for a Q&A following the presentation, and as always, this event is being taped and will be made available later on this afternoon at datasciencecentral.com. I would also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host for today's webinar. I'm very pleased to introduce today's speakers, Dan Donovan of Lavastorm Analytics and Dustin Smith of Tableau Software. Dan is the head of partner development responsible for Lavastorm's partner relationships globally. With more than 14 years of experience in the software and telecommunications industries, Dan now has a strategic focus on building and growing Lavastorm's ecosystem of leading solution and technology partners. Dustin is a product marketing and community manager at Tableau Software. Formerly a data analyst and senior product consultant, Dustin is now a full-time Tableau user evangelist. He specializes in effective data visualization and teaching others how to convey metrics beyond the data crowd. So thank you both for being with us this morning. We're looking forward to your presentation. Using data to drive decision-making and innovation inside an organization is no longer the practice of just a few companies, but rather a core competency required of every business and institution at nearly every level. The inefficiencies inherent in how most organizations approach data today stems from a multitude of factors. Advances in data management and data visualization are helping to redefine how both individuals and organizations analyze data to make key decisions and drive additional insight in even shorter spans of time. In today's webinar, you will learn how savvy organizations are quickly overcoming data preparation obstacles, how dealing with multiple types of data is now a solved problem, how creating scalable data processes and pipelines is now a capability of the everyday data user, and finally, how quickly data visualization can be used to analyze and discover insight within even massive data sets. So with that, Dan, I'm going to transfer this over to you, and you can begin as soon as you're ready to go.
Dan, all right, thanks, Tim. And
yep.
Yes. Thanks for that, Tim, and thanks everyone for joining us today. So as Tim mentioned, the topic today is combining data visualization and data management to achieve faster results. So by way of format, I'm going to be covering, focusing mainly on the data management piece of this and showing the interface between data management and data visualization and how we're working together as an industry kind of to solve a group of problems. And then Dustin Smith from Tableau will cover the visualization piece and sort of how end users can make use of this combination of technologies to solve problems. So if we think about the traditional approach to solving analytic problems within a business, you have on the right-hand side of this slide business users, people within lines of business, within organizations who are traditionally and still consumers of the results of analytics. So in a traditional kind of process, this group of people spends a lot of time gathering and documenting requirements and then throwing those over the wall to the left-hand side of this diagram where the producers of those analytics live. And that's normally traditionally been within an IT organization, people with very technical developer type skill sets. Then they wait for a set of results to be developed and produced and pushed back across the wall to the people who understand the business requirements and have questions of the data. And normally this follows a software development lifecycle sort of approach, where the initial set of requirements will get you 70 or 80% of the way there. Then there's a long cycle of change requests with further and updated requirements, which are thrown back across this wall to the producers of those results, which are then again pushed back to the people within the business who are actually making use of the analytics. And this is a slow process. The time to market is typically measured in months or even years for larger analytic projects. The barriers to entry for analytics projects in this traditional model are quite high. Also, the accuracy is lower and slow to improve because of this disconnect between the people who understand the business requirements at their core and the people who are producing the technological solution to give those results to find answers within that business process. The scope of these projects can be limited by a number of factors, including just the general disconnect between the producers and consumers, the overall cost that results from the bottleneck of skill sets within an IT organization on the producer side here, and any number of other factors, including infrastructure costs and licensing and support costs for the infrastructure required to produce these results. So what we're do in today's world is to change the way we think about this so that we're blending together the business users or the consumers of analytics and the producers of those analytics, so that the production of analytic models and production of things that people do with data becomes much closer to the actual business use cases and the actual drivers of these analytic questions. So this improves the time to market because you have everyone working together in an agile kind of iterative way that allows you to produce results very quickly, cutting out that requirements documenting process. And instead of capturing things in a document, you have people actually producing live analytic models in about the same amount of time that you could normally just write down and capture the requirements. The other thing is there's a continual improvement process through iteration here. So by really getting your hands dirty and looking at the data as you're doing this and letting the data inform the requirements themselves and the decisions you make about which analytic paths to pursue as you're building out some of these analytic models, it becomes much more of a discovery process. And you start to facilitate conversations between technical people in IT and business people in the lines of business that maybe have never been possible before. This just leads to a much more efficient process across the board and to much faster results coming from your analytics. So we really see this as sort of a combination or intersection of three sets of capabilities. The first being an Agile ETL layer that allows business users and people without a developer kind of skill set to have access to data no matter what the source of that data is. So in a typical enterprise organization in any industry vertical, you have a whole collection of systems that might range from old legacy systems that are written in COBOL that generate data in EBCDIC encoded complex binary formats, all the way up to modern data warehouses and data marts, which tend to be sort of spread all across an organization as well. Now there's a lot of investment being made in big data infrastructure, technologies like Hadoop and MongoDB and those sorts of things. You have data that used to almost entirely live on-premise within an enterprise now being spread into the cloud as well, with great cloud providers like Salesforce.com and Workday, and all of these data sources need to be combined in order to answer analytic questions within the business. So part of the idea of data discovery and the thing that Gardner and other analysts refer to as the data flow piece of data discovery is an Agile ETL layer that gives access to all of those various data sources and the ability to bring them together into a common analytic environment where people who understand business problems that you're trying to solve can actually work with that data. So that feeds this idea of an analytics modeling environment that is not involving traditional programming or even a lot of scripting these days. So one of the things that we provide in our lavastorm analytics engine is a very graphical drag and drop kind of environment for configuring in a rapid manner quite complex business rules around data. So not only kind of predictive and statistical modeling that people tend to do with data, but also very operational kinds of analytics. And so the ability to do this in a non-programming, non-development environment serves two purposes. One is to enable the business to become much more self-reliant and self-sufficient in the way that they approach analytic problems. The other is to relieve some of the bottleneck that's happening in IT. It's quite typical in an enterprise today to have the business ask as a request for an analytic project or an analytic data set to be made available by IT. And the answer, because of the incredible number of requests that IT departments have coming in from the business, is normally that it's going to take months to get that done and at quite a high internal cost. So one way to reduce that barrier to entry to these projects is to allow people with more broadly available business and data analyst skill sets within the line of business to configure some of these rules themselves. But if you listen also to what the analysts are saying about the future direction of analytics and data discovery in general, things are moving much more towards a governed data discovery environment. And so part of what the data flow tools provide as well is a way for that governance to happen. So a way for IT to control or at least exert some governance over what people are doing and provide some consistency across an enterprise in a way that people are working with data so that you don't end up with the same kind of problem that you have today with end user developed applications in tools like Excel and Access where there's not as much consistency and sophistication, and it becomes very hard to maintain a large set of analytics across an enterprise. From our point of view then, on the data management side, the results of these analytics and all the nice, clean, flat, enriched sets of data that are made available along the way as data flows through a model that you design in this visual environment, it can then be pushed out immediately and published to visualization environments like Tableau, where you can then reach a much broader scope of end users who can actually get in and do amazing things with the data, such as the things that you'll see Dustin showing in a few minutes. So this is an overall sort of picture of that data discovery, data flow kind of environment. So you have data coming in on the left-hand side here from lots of different sources that could be spread all over the enterprise, pushing into a visual model that's been designed by someone who understands the business process at hand that you're trying to analyze or audit or whatever you're trying to do. And then that is publishing out results into end user applications like Tableau, or it could also be pushing things back into operational systems. So you could be updating data, you can automate these processes so that things happen automatically when discrepancies between systems are found. You can do things like open up a case in a case management system so that someone can go in and investigate the root cause of those discrepancies, or any number of things through various extension points that you see at the bottom here. You can reach out to external systems and actually affect changes in source systems in some cases. So what I'll do now is I'm going to go into a completed model of an analytic solution within our lavastorm analytics engine, and I'll show you what this looks like and how the interface works with Tableau. So if we just wait for the streaming to buffer here. There we go. So hopefully everyone can see my screen now. So this is what one of these analytic flows looks like. And the way that this works in general is we have these libraries of individual nodes of functionality that you see down at the bottom of the screen here. So these libraries are divided into functional categories in this case, and these represent all kinds of operations that you can perform on data, things that you can do to bring data into the system through data acquisition. So you can see just some of the formats here that we can deal with just by dragging and dropping these nodes. Various ways to aggregate and transform data, so a lot of that ETL kind of functionality. Ways to correlate and blend and match data sets together, so a lot of data integration and data quality functionality built in here. Pretty much anything that you'd want to do with data, there's a node that allows you to do it. And we at lavastorm release a lot of these nodes on a continual basis. So every 2 or 3 weeks we have a new release of nodes that auto-update into this core library of things that you can do with data. In this case, the example that we're looking at is an analysis of a trading operation within a major investment bank. And it's the process that we're looking at is actually a currency trading operation. So it's a pretty typical trading operation in that there's a front office system where traders enter details of a trade. So this might be trading US dollars for euros, for example. So they'll enter all of the economic details of that trade and when it's supposed to execute and all of that. That flows into a risk management engine, and we're reading in some of that risk management data here. This is data about those trades. So the risk management engine will do a lot of calculations and kind of predictive modeling of risk around a given trade. And it may create multiple versions of that trade. So these nodes on the screen that look like stacks of boxes are actually composite nodes. So if I double click on one of these, it will drill inside there, and we can see what's going on inside. So there are several steps here that have been configured, and this is really the ETL kind of portion of this that's just cleaning up that data a little bit, doing things like converting fields, and it's all quite simple, the operations that need to be performed to this data. But this data could be coming from very complex data sources. But once you've pulled it into this analytic environment, then anyone can work with it, and all the data sets become equivalent, whether they came from a spreadsheet or a binary file extract or a CSV file or a database or a data warehouse. So one of the things that makes this a real data discovery process is that at any point along the way here, I can double click on any of these inputs or outputs to these individual steps, and I can see the data at that point. So this is some of that risk management data, and I can kind of sort and group the data here. So I can see this is a single trade. It has 10 different versions in that risk management data set. And then there are a lot of details about that trade. So the economic terms and where it's meant to be executed and all of those kinds of things. On the other side then, some of those versions from the risk management system will flow into a settlement system that does a lot of validation and actually tries to execute the trade with whatever counterparty the trade is being made with. The settlement data looks quite different. So if we look at that after it's been cleaned up a little bit, we have those same kind of system IDs here, so we can identify which trade it is. But the version IDs have been overwritten with zeros in a lot of cases. This is an old COBOL-based system, so space was quite a precious commodity when this thing came out. And this is typical in a lot of older systems that are still around. So you lose a lot of data. Not only does it overwrite the version IDs here, it also overwrites the timestamps that are coming out of that risk management system. So the problem that the bank had here is there's no good way to match this data up using the tools that they were trying to use within the business. So, and you know, just like the rest of the world, a lot of those analysts within the business are still using tools like Excel and Access, and just the wrong tool for this kind of data crunching job. So inside here, what we're doing is pretty kind of matching those trades together. So you'll see this node that's called an XREF or a cross-reference node. So we have our settlement errors data coming in here. These are all of the versions of the error, because the cost of this trading operation comes from people having to manually intervene with these trades in order to correct problems and get them to flow through. On the other side, we have the risk management data, which is where the trades came from. And what we're trying to do here is to match those two sets together. So you notice back in our settlement errors data, sometimes the version ID is there. Sometimes the settlement system leaves it alone. So the first thing we do here is to try an exact match. If I open this node up, you'll see the configuration, and I'm literally just specifying a key on which to match. So it's that system ID and the version ID combined on both sides that we're using. And that's all the configuration it takes. Then when you run this step, you get all three potentially interesting sets of results on the right here on the output side of the node. So I can see all of the records that matched, and we take those and push them over into a bucket here where we're collecting all the matches. But just as importantly, I can see all the ones that didn't match, whether they were only in the settlement errors data or whether they were only in the risk management data. Then we can take those and progressively apply fuzzy logic to them. So there's a fuzzy logic version of this node that allows us to specify that the system ID should match exactly, but we also have a fuzzy logic section here that can take the timestamps and compare them. So someone within the business, a subject matter expert in the business, said, well, these timestamps are almost always within 10 seconds of each other because what the settlement system is overriding it with is the time it was received. So we have the time it was sent from risk management and the time it was received from the settlement system. So we can use fuzzy logic here to match those up. This also supports lots of other fuzzy matching algorithms, looking at text strings, so you can see the number of characters that are different between those text strings. It can do a soundex lookup, so things that sound alike. So for example, if you have two customer systems and you have a customer named Sean, and in one system someone has spelled his name S-E-A-N, and the other one it's spelled S-H-A-W-N, that'll have a very low soundex score. You can look for typos and transpose digits. Really anything you can calculate as a numeric value within the data, you can set a threshold here for fuzzy matching. So, and then again, you get on separate output streams here, all of the matches that match uniquely. You can see anything that matched multiple records within that threshold, and you can also see everything that didn't match. So at the end of this process, we have a nice new view of the trades that the bank didn't have before, and that is, this is the same trade we were looking at before. I can see that it had 10 versions in risk management, but I can immediately see which two versions caused problems in settlement. So one of the things that we do with this set of data then, this gives us a fully enriched data set. So we can see all of the error data from the settlement system. We can also see all of the details of the trade from the risk management system. And so we can take that data set and push it out into Tableau here as a native TDE file, which is a native format for Tableau that doesn't require any kind of scripting or input work on the Tableau side. It can just take that, and that's what Dustin is going to show you rather in just a few minutes, is what we can do with that data then in a tool like Tableau. But then within our data management tool here, our lavastorm analytics engine, we go on to do some further analysis. So we can start to look at patterns within that error data, right? So we can start to see things like error sequences. So for this particular type of trade, we almost always see these two errors in this pattern, in this sequence. And so with a little further investigation, we're able to determine the cause of the first error and do some sandbox sort of what-if testing here and see that if that error never happens, then the second error never happens either. And so you can really start to get very operational in the kinds of analytics that you do. We also can start to calculate the cost of a trade. So if we know which teams these people sit on who have to intervene with these trades and how much their time costs, you can start to estimate a real cost of a trade, rather than the way that a lot of banks used to define cost of a trade is to take the entire trading operations budget for last year and divide by the number of trades that were executed, which doesn't really give you a complete picture of what's going on. Most data management tools like our lavastorm analytics engine don't focus a lot on visualization of data. That's why we partner with companies like Tableau to do that. You can see our extensive visualization here. There's just static charts that you can drop in as you're working with this data. But I can also use Tableau interactively here. If I right-click on any of these data sets, I have Tableau configured here as a data viewer, so if I select that, it will just pop up Tableau and create a Tableau data extract on the fly in the background. So really, this is the data management piece of this. It could be much more extensive than this. The example I'm showing you here was done as a proof of concept for this customer, and all of this analysis was accomplished in 2 days. From just walking in the door, not being familiar with their systems or their data, in the hands of a consultant who's familiar with using this tool but not familiar with their business, we're able to get all of this data brought in, aligned, matched up, and analyzed within a couple of days. And we're actually able to show enough value to the customer in that couple of days to justify doing a much larger project, a much larger implementation. So I think really the power of this methodology of using this style of iterative, rapid development of analytic models feeding into visualization platforms that allow you to see immediately a lot of insight from that data. That's one example of how you get an almost immediate return on the investment that you make in the time and the software and the technology that it takes to do this. So to talk about the other side of things and how this feeds into a visualization-based data discovery process, I'm going to hand it over to Dustin from Tableau.
Fantastic. Thank you so much, Dan. Hello, everyone. My name is Dustin Smith, and I am a product marketing manager at Tableau Software. I am so excited to be a part of this webinar today just because from a Tableau standpoint, solutions like lavastorm are the quintessential pairing for the everyday data worker. And as Dan talked about, it is expected now, whether people know it or not, that it's not just about living inside of Access and Excel or munging through CSVs, that the necessity of being able to take disgusting data sets, and I mean messy, hairy, horrendous, as Dan pointed out, old COBOL systems that are rewriting things and then jam them together with other messy data sets. Those aren't things you can do inside of the normal applications these days, but they are more and more becoming an everyday data worker's requirement. And that back and forth with IT just doesn't cut it anymore. It's just not something that anyone has time to really do to push innovation and insight. And so the marriage there between lavastorm and Tableau is a beautiful one because Tableau's mission statement to help people see and understand data, whether you are using Tableau first, understanding that you are missing data and you need to go find more, and then you're going to actually use lavastorm as an application to marry together and bring in and do additional analytics before it even gets to Tableau, or whether you start with lavastorm as the front part of it and then use Tableau as a data discovery and then reporting, and then there's this kind of iterative data cycle. Whatever combination of process steps that you do therein, there's this beautiful back and forth that happens between, okay, I can see my data, now I need to go add more to it or do different things with it. And so what I'd like to do today is just talk really quickly about kind of why Tableau focuses on the visual component and the importance that brings to the data iterative cycle. And then I'm actually going to show you a little example of Tableau using that same data set that Dan just walked through. So if we go through here, as humans, let me just take a step back and talk theoretically. Tableau's focus on the visual data discovery, not just spitting out rows and columns or not just spitting out basic chunks of data, but why we focus so heavily on a visual component. If we look at a text table like this, our eyes, our brains are pre-tuned to look at things like color and shape and size and do all sorts of stuff. So if I asked here, who can spot the least profitable categories of, looks like we're selling school supplies or something like that, or furniture or something like that, your brain is going to do this mental table scan, up, down, left to right, when in actuality, it's faster for us if I ask that same question and I have a visual like this. This is data visualization. The previous one was too, but this is adding just that concept of color to those areas that have negative profitability. So immediately, instead of trying to process columns and columns and 50 different items, my brain is actually able to segment and almost kind of index between, okay, here negative, here's not negative based on color. And then again, if I ask the question, okay, well, it's not just negative, it's those that are really, really profitable, but more importantly, what about those ones that are right in the middle? The ability to kind of take that in as a whole, right? So this is the concept of using data visualized, both color as well as the actual shape and size of the visual itself, right? So this case, a bar chart. This is so much more a complete picture of that data than what we started with. This is so much more telling. This is the story inside the data. And again, this is such a critical part, is what Dan talked about with lavastorm, is we know that there are stories inside of those data, the data that we get, right? Even if the story is, this data is disgusting, right? Everyone's saying that this is the right data set when in actuality it's the wrong one. There's too many nulls, or it's not clean, or it is, for whatever reason, we need to go join it up, blend it in, do additional analytic properties on it. Whatever that is, right, there is an insight that can be had to drive the business further. So what I would like to do at this point, and my last slide here, this is really this overarching thing. You've heard me mention it, the cycle of analysis, whether it's visual data analysis or data analysis in general. All of this comes back to the idea that whether we're just looking up, our most recent sales quotas, or we're trying to understand currency transactions that are in some sort of error state, as Dan was using, and we're going to look at here in a second. Higher ed information around student surveys, nursing information around rotation. I mean, everywhere there is data, and everywhere we are trying to leverage it to do our jobs better, to improve quality of life, to better education, to improve financial service. I mean, you name it. And that task is always the same, right? What is the thing I'm trying to accomplish? How do I get the data? How do I find the structure of the data that I want? What is the view that is best? We're going to talk a little bit about view here in a second. Develop insight, and then I'm going to act on it, right, based on the things that I've found, right? And sometimes acting on it is a whole new data task. And again, this is this little slide I have up in front of you, literally, right? I'm almost in my mind saying, okay, here's where I would use lavastorm, here's where I would use Tableau, here's where I would use lavastorm, here's where I'd use Tableau, back and forth, back and forth. And the power to do that in a single person's universe, right? Let IT deal with the things that are strategic to IT. Let the business user who is familiar and a domain expert with that data grapple with the data. So let me switch gears here, and actually I'm going to share my screen. Give me 2 seconds to make sure it's looking good here. Perfect. I like it. And I'll go ahead and launch it. There we go. Hopefully we are buffering there for a second. What I'd like to do is actually show you, so what you should be seeing now is a finished Tableau dashboard, right, pointed at that data set that Dan was working through, currency transactions, risk management, error handling. I mean, this is kind of the end state, right? This is where everyone wants to be. This is the ability to understand of all of those transactions, the US dollar followed by like, ooh, it looks like the Malaysian currency, then the euro is down here, right? Understanding, and in a click of a button, right, not just the makeup of those transactions, but what was the volume of those transactions over time, right? What was the average cost on those trades happening? Who were the major currency transaction customers? But most importantly, maybe what were, in that average cost, what was the percent difference over time? I mean, this is a deeply analytical dashboard, and if you're actively trying to hunt down, you're actively trying to understand, okay, why do we have some of these transactions in risk states? Is it related to any one of these things? A dashboard like this is critical, right? And the data behind it being current. And the power that when something else needs to change about this, it's not a requirements doc submitted to IT. It is the person who is looking at this can go in and change things in real time, right? Especially in the high stakes world of financial services where it's so fast, right? Time is money. And time is innovation. Time is insight. Time is all of the things that we're trying to get to. That's the delimiter. But let's just back up a step. I'm going to hide that real quick. Dan went through an entire analytical process and data process and created a pipeline that is scalable and reusable inside of lavastorm. And what he did is he output a chunk of data. And he output it in something called the Tableau data extract, which is just a little file that sits in memory. And even big data sets get compressed, and they're really nice, and they're proprietary for Tableau, and they spin up real quickly. And this is what that looks like, right? This is that enriched RMS data that Dan sent over to me. And all I have to do to bring it up in Tableau is this. Double-click, and Tableau desktop, which lives on my computer, in 2 clicks, I'm connected to this data set. And so remember what Dan was doing. He was working through those nodes and bringing those different data sets together, right? Risk reporting, right? Risk management, error reporting. Here's all of that data pushed together in such a way that allows me in an easy drag and drop. I didn't have to script. I didn't have to know any coding. I didn't even touch my keyboard to do this. This is Tableau desktop. I can ask questions now. Okay, well, this is a currency ID, right? Different types of currency. And if this is my total number of records, transactions, I can use something in Tableau called the Show Me dialog, which is like a visual best practice recommendation engine. And it's saying, you could build simple bar chart just in a single click. Right? It looks like I actually have a bunch of null data here. Discovery number 1, right? There's a bunch of data that I may need to go take a look at later on. Maybe, though, what I really want to see is kind of this part to whole of all the currencies that are getting traded and in transactions. What is the overall makeup? And so now I've just built a tree map. And I can start to ask more questions. Okay, well, if all of these transactions, right, this is the US dollar, here's the Malaysian currency, here's the euro, there's the yen. Maybe I want to know a little more about this, right? There's this concept of what state they are in. Are they canceled? Is it expired? Let me go find that status right here. And so I might say, okay, well, if I just want to see, oh, look at that. Interesting. Now I've got each one of these. And actually, what I'm going to do is I'm going to take that status and I'm going to make that the color. And then I'm going to take that status and drag it above right here. And I'm moving pretty quickly, right? You're watching me drag all these pieces of data around, and it's flying around on Tableau desktop. And that's kind of the point, is I'm moving incredibly fast with some complicated data, but I'm not writing script to do it. I'm not thinking about queries. I'm literally asking the question of all the records I have for this data set. How do I understand which currencies, right, make up the bulk of that, and then inside of those currencies, which ones are in what states? And how do I get that really top-down view from that? And this is just one way to do it, right? It looks like we've got a bunch of these weird random little ones out here. I'm actually going to get rid of a bunch of them here real quickly. I'm just going to go exclude, and I'm going to exclude this one too. And then I'm just going to change up the colors on this. And I'm taking a little extra time to format this just to show you, you can switch from I'm in analysis mode to, okay, I now have to format this a little bit because I'm going to switch gears and actually present my findings to someone. So let me just stop real quick. I started, or Dan started, with disgusting data. I mean, it was not pretty at all. And that's a regular occurrence for anybody in the data business. And through the course of visually being able to drag and move around different nodes to solve and make that data clean or more analytically rich, right? He built a visual scalable process, a data pipeline that he can leverage again and again and again. He's done with that operation. And then it outputs rows and columns of data that within seconds I've actually, in a visual manner without any heavy-duty scripting or coding background, answered an interesting question. If we're thinking about currency transactions, we're thinking about those that are in an error state. Right? What does that look like from a total number of currency, from the statuses they're in? If I'm going to tackle this project, right, I have to dig into this and understand a little more, okay, how am I going to handle these? How am I going to prioritize these? How am I going to convey this information to those on my team, my clients, my vendors, my partners? I mean, whatever. How quickly can I do that? So this was just a quick example, and where a finished product might look something like this. And no smoke and mirrors. I just took about 15 minutes more to build this dashboard out, same data set. And all I've done is gone through and built out varying sets of analyses into different sheets inside of Tableau, put them together on a dashboard, and then built some very light interactivity that allows me to click and immediately drive different insight. So if we are going to look at the Japanese euro, an understanding for the time frame of July 30th through September 28th, right? Here's total volume, a big spike, right? Average cost, and then here are the major RMS customers they're dealing with. And the really interesting thing I love about this, right, is the ability to show percent difference in average cost, right? Understand over time. Let's look at that one just for the U.S. Right? What is actually happening, not the actuals, but what are the differentials that are happening in that average cost? Is that an indicator, right? Is that causing some of the error handling that we're looking at? I can drill in and look at the underlying data on any one of these at any given time. So all of this to say, and back up, when we think about that visual of data analysis, that cycle of going through and answering questions, right? It is so rare that even when we have a beautiful dashboard like this, that is the end state, right? This is prompting all sorts of questions, I guarantee you. And 90% of those are going to require additional data. More importantly, the data we started with probably wasn't clean to begin with, right? Or required combinations of data. And it wasn't a situation where IT was going to jump in and help us out on the spot, right? They have their own strategic priorities. So the ability to get to this state, even when it's multiple data sources and it's just horrendous, using lavastorm, using the everyday person's knowledge about their job and the data they use, going through that cycle of data analysis of, okay, I've got my data, I need to find the structure, quickly and seamlessly moving from lavastorm into Tableau by just outputting a Tableau data extract, double-clicking, opening, and answering questions. For someone like me that used to live the life of just trying to debug Excel calculations and just crying because my VLOOKUP wasn't working, or begging my database administrator to give me one more year's worth of data to edit that SQL query that he already spent way too much time on, right? That lost time is a thing of the past. With today's technology, with the symbiotic relationship between lavastorm and Tableau, right, being able to move quickly and easily between those solutions to achieve that real-time cycle, that is the reality. And more importantly, that is the requirement that so many people's jobs have, and it's not written into the job description either, right? The job is to find insight. The job is to drive innovation. The job is to find what's wrong and fix it. And more often, data is your primary tool. So with that, I am going to go ahead and flip it back to Dan. Go ahead and push that to the audience there. So go ahead and take it away there, Dan.
Sure. Thanks, Dustin. So, yeah, I mean, if you're interested in seeing this sort of live with your data, both lavastorm and Tableau have free public versions of our software available on our websites, as you can see there. Also, my contact information and Dustin's contact information are on this slide. And we'd be happy to talk more about this process and sort of do an interactive demo with your data, or even a proof of concept if you have a data management or a data discovery kind of analytic problem that you're struggling with. We're happy to help, or even just start a general discussion through some of the forums on Data Science Central, or some of the other places that you see us around, LinkedIn groups and things like that. This is really for me, an exciting space to be in right now, because organizations all across the board are really changing the way that they work with data. And it's exciting to be part of the technology that is enabling that. So with that, I think I will send it back to Tim and see if we have some questions. Or
Great presentation, you guys. I really love the live demo. It always adds such a great dimension to see the products in a real world sort of setting and see them actually crunching all this data. So excellent job. So yes, we do have some questions coming in. Audience, again, feel free to continue to ask questions as we go through this portion. I'm going to advance the slide here to our Q&A slide. Again, both Dan and Dustin's email addresses are listed there. Feel free to take them down, and you can reach out to them following our webinar today. So the first question I'm going to ask today is for Dan. Dan, what types of files or data are you able to combine using the lavastorm engine?
Sure. So it's pretty much any type of data that you can imagine within an enterprise organization. So specific things that we have the capability built right into the core product to read. I mean, we can connect to any type of database or data warehouse that's out there. For more technical people in the audience, we support ODBC and JDBC connections to those databases, as well as native interfaces to Oracle and Teradata and some other database vendors. The file-based extracts that we can read, it's everything from well-organized, simple things like CSV extracts and other types of delimited files. You can read Excel spreadsheets. You can read binary file extracts from old systems. So things like COBOL extracts, you can literally take a COBOL copybook and paste that into one of our nodes, and that node will use that as metadata to process a file extract in that format. Same thing with other binary formats like ASN1 or other complex things. And our binary data reader is actually tunable down to the bit level, so you can read literally anything that can be represented in a binary file. Other types of structured data like XML or those types of things, you can pull data from web services directly from that model that you build visually within our analytics engine. So a wide variety of data sources. I mean, the goal from the very beginning of our product, which has been on the market for 12 years, was that data analysts within the business should be able to get access to any kind of data they need in order to answer their analytic questions.
Very good. Great answer. This question is for Dustin. Dustin, can Tableau read a SAS data set?
That's a great question. We don't read in SAS data sets directly in the same way that we, connect directly to Excel or, things like that. A lot of times folks will use an in-between product or they'll output into something. We would love to work with SAS, and one of the things that was always on our roadmap is how can we expand our technology integrations to better leverage those resources that the customers are using to do data that they consider their data environment.
Okay. Thanks for that answer. This can be for both of you guys. Is there a trial version that folks can use, and if so, are all the features that were shown today available for that trial?
So I can answer from the
Oh, go ahead, Dan.
The lavastorm side, yes. In fact, the trial version that you can download straight from our website is a 30-day trial of our Professional Plus desktop edition. So that includes all of the nodes that I've been talking about, as well as a lot of other ones. So it's a full-on version of the software that works for 30 days. The only limitation of that version of the software is that the analysis that you're doing is limited to 10 million records. With our commercial versions of the software and the server versions, you can scale that up infinitely, essentially. We have some environments that are processing billions of records per day.
Excellent. Dustin, you want to jump in real quick?
Yeah. Same answer on the Tableau side. You saw me using Tableau Desktop Professional, which our free trial is fully functional. And then, the part I didn't talk about and didn't show was we also have a server, collaboration software that you publish those workbooks up to, and there's a full trial that's fully functional, install on your hardware or your VM and be up and running. So, yeah, fully functional, both trials.
Okay, and in line with that question, are these both products sold or potentially sold as a bundle?
This is Dustin.
So
you can absolutely buy Tableau Desktop and Tableau Server as a bundle. They are separate products. We always want to be really clear because you can absolutely use Tableau Desktop without Tableau Server. But yeah, you can package them together any way you want. We're about flexibility when it comes to a solution you want to buy at Tableau.
Okay, excellent.
Yeah, and it's the same on the lavastorm side for our products. I mean, you can start with the desktop version, use that to do enough analysis to prove an ROI for a much bigger implementation. And if the question is about buying lavastorm and Tableau together, then yes, I mean, we are technology partners, and we work together to sell these as a more cohesive solution all the time. And we also have some mutual solution partners who do the same.
Okay, excellent. That's good to know. A few questions have come in just in terms of proficiency and level of aptitude a user might need to have for both the products. So Dustin, why don't you go first? One of the questions is, how long does it take to become proficient? Do they need to know SQL or R? Maybe you can just talk a little bit about that, and then Dan, why don't you take the same question following Dustin?
That's a great question. The answer is, you have to like data. You have to be tasked with a data project, but the skill required, you don't need to know SQL. You don't need to know R. You don't have to have, a database administrator level experience. Largely, it is people who do a little bit in Excel. The better you are in Excel, if you do have a SQL background, right, some concepts are going to be clear, but we regularly see people pick up Tableau for the first time, and within 30 minutes, they're already answering basic questions about their data. We regularly see people inside of 14 days leveraging Tableau as a normal user. It's again 14 days in the concept of I'm going to spend 20 minutes a day watching a video or something like that. I've also seen people just go absolutely wild with it, and in a 48-hour period are reproducing everything they've ever done in Excel in a fraction of the time, and even going beyond that, bringing in other data sources and things like that.
Great. Thanks for that answer, Dustin. Dan, go ahead.
Yeah, so on the lavastorm side, I mean, even though we're doing a more technical thing on the surface than what you're doing in Tableau normally. I mean, the design of these ETL processes and data flows and analytic models, we have the same sort of target user base. Maybe I would say that our target user is someone who's kind of a power user of Excel, or someone who you can get started with the product even if you're just writing basic formulas in Excel and understanding data at that level. You get a lot more out of the product if you have a little bit deeper data skill set than that. Maybe you've created some applications using something like Access, or certainly if you have a database type background, then the product would be no problem for you. As far as typical ramp-up time, we have a 3-day product training course. And then just like Dustin said about Tableau, I mean, usually after that course and then using the product for 2 or 3 weeks on an actual project that means something to you, that's kind of the best way to get up to speed and really understand what you're doing. Okay,
excellent. So Dustin, a question for you regarding the Tableau software is there a limit to the amount or size of data that it can handle?
Great question. The answer is no, and the reason for that is Tableau, kind of connects to your data in whatever way makes sense. As in, you have, a massive data set, or lavastorm is built a pipeline that is pushing through a massive data set. Tableau is going to sit on top of that data set, and so the performance or the size of data it can connect to is purely governed by whatever your data environment is. Conversely, right, if some people have antiquated data environments that aren't set up for live querying or whatever situation, you can also do an in-memory extract, and that effectively says, I'm going to take a static snapshot of this data, bring it in memory in a local file. That's exactly what we worked with today, was the little Tableau data extract, optimized and compressed for speed for Tableau. I regularly take 10, 12, 30 million row extracts. It's not a problem at all. It happens in minutes. We have heard of people taking billion row extracts, right? That's, from an in-memory standpoint, you start literally, what is the RAM on my computer? But there really is no limit to the data it can connect to directly. It is purely around what is the data environment? How does it handle the processes that our Tableau is working with?
Incredible, great answer. So Dan, this is a question for you. Are there any data formats that lavastorm currently is not able to process, or is it pretty much across the board, any rough, ugly data in all formats, can it process it?
Yeah, so I mean, this is going to sound like a sales answer, but it's the truth. I've been working with lavastorm for a little over 9 years, and I've not yet run into a data source that we can't read. Some very complex, as Dustin would call them, disgusting data sources take a bit of effort to configure lavastorm to read it, and by that I mean if you have a really complex custom kind of binary format that you're reading from a mainframe or something like that, it can take, it's measured in hours, not weeks, but it can take some configuration effort. For the most part, 95% of the data formats that you need to read, we've seen before, and they're already incorporated into the product. So, I've never run into one that we absolutely couldn't read.
It's incredible. A question sort of in line with this is, Tendi wants to know if you can estimate the processing time to performing in terms of merging data, something as large as 100,000 records. Can you give an estimate of what that would take in just straight time?
Sure. 100,000 records is seconds, no matter what kind of hardware you're running on. On my laptop, that in that example that we were looking at before, it's merging a couple 100,000 records on each side in I think less than 2 seconds. The real determination of scale with our analytics engine depends on the data set that you're working with, how wide is it, how complex is it, and then also the hardware that you're running on. Essentially, our software looks at the available CPU capacity and RAM and everything. It's just a collection of processors and storage locations out there ready to receive and process data. So you can scale that up to parallelize things across multiple processors, and you can determine your own performance by the amount of hardware and that you're throwing at the problem. But for something like 100,000 records or even 1 million records, you can comfortably handle that on a laptop. And those individual join or cross-reference processes that you saw me running would just take seconds.
Very cool. Dustin, a question for you. Can you go into some detail where you see the advantages of using Tableau compared to using something like R?
That's a good question. I honestly don't view it in terms of advantage, disadvantage. I just view it in terms of what are you trying to do. Tableau has an R integration where, if you've got an R serve stood up and you've got a k-means clustering package or something like that, and you want to leverage that with Tableau, Tableau has the ability to, inside of our calculated field window, which I didn't show, but it's a right click and you just write stuff. You just pass results into RServe and it passes it back. And so we see it as a complementary scenario. If you're using R to do what we consider to be basic data analysis, right? Maybe it's just running a simple trend line, or it's trying to understand a p-value, right, or something like that. I would say it's probably faster, and you won't even touch your mouse or you won't even touch your keyboard in order to do that in Tableau. But I see it really, use R for what R is good for, right? Or leverage other products that are going to do that. Use Tableau to get to the answer faster after the data has been analyzed in whatever package you're using or something like that. So it's not good, not bad. It's kind of a high-end stats. Use R, right? When you're ready to bring that in and build that as part of your visual analytics process, work it right into your Tableau process.
Very good. So we have a lot of questions that came in, and I want to jump real quickly, audience, before you depart. And in the spirit of ending on time, we have a quick poll that I'd like to ask you all to participate, just to get an idea of where you all are in terms of your interests. So if you see the poll in front of you, just take a moment to check the appropriate box. So where does your main interest lie? Is it data management, data visualization, both, or you're simply not sure? Any answer is appropriate. So if you could just quickly mark that, and then we'll proceed forward. We'll get a quick glimpse of the results so everyone can see them. And again, the questions that were asked, thank you for participating and asking some great questions. All the questions that were not answered today, I will be sending them to Dustin and Dan, and they will be getting back to you. And hopefully you guys took down their information so you can reach out to them as well. So let's proceed forward. There you go. There's a quick visual of what everybody does. Nobody's not sure, so that's excellent. So with that, I'm going to move forward here. Just have a couple of quick announcements to make. To please mark your calendars for September 2nd and our next Data Science Central webinar, which is Hadoop Deployment, Best Practices, Scalability, Robustness, Flexibility, which is sponsored by Trace3. This brings our webinar to a close. I'd like to thank our audience again for their participation and thoughtful questions. And again, a special thank you to both lavastorm and Tableau for their sponsorship, and of course Dan and Dustin for a great presentation, some great insight, and just being so knowledgeable of your specialty here. So thanks again to you both, and we will look forward to seeing you all again on September 2nd. Good day.